In this chapter, we'll see the first part of the grain applied to the skull. So now that we have created the clusters earlier, I would like to use it inside a pop simulation with the grain system. So let's isolate it with a split. Just there. And I'm going to use the @active cluster equal 1 from the primitive. But if I check there, actually I don't have it. So let's add it like this. And here I do have the active cluster. So I just have to recache it. But because it's a static attribute, I don't need to recache all the points, but just one frame. So let's do it there. Okay. And go back here. So I should have this one. So this is good. And what about the invert? Okay. So I'm going to use the first input for the set P from rest position and create a new row for the other one for the clusters. Okay. So now I'm just going to fuse it with a small value, and with the match attribute I'm going to use my cluster P because I have to iterate over points for the fuse, but actually I realized that I don't have it. Oh, and I need to add the error there. So let's add it to the clean, except my cluster P, and it's there. So let's recache it. Okay, and now it should work. Yes. I don't want to make the fuse over each frame, so let's just freeze the first one. And let's go to the global control, copy like this, and pass relative reference. And now I would like to convert line with the rest length and add an attribute pscale. So let's create a grid just to show you with something like a remesh. Maybe not that high, let's say 0.5, and the convert line as well. So in order to create the pscale, I would like to use the rest length. So let's use an attribute promote to say from the primitive to the detailer, I want to use the rest length. I don't want to delete the original, but I want the minimum. And let's change the name to pscale. Now I would like to go back with an attribute promote from the detailer to the point, so my pscale with the average method. And I just would like to check copy to point with a sphere. And this is my pscale. But actually here I was setting the diameter, not the radius. So, I mean the radius, not the diameter. So I need to change it to set at f@pscale times equal 0.5, and to have just a bit of more security, let's say 45. And now this is the correct pscale. I mean a pscale that I can use without interpenetration, and let's say with a consistent size. So I'm just going to rename it the pscale new attribute. Let's make it red. I don't want that anymore. I just want view and view. So I should have my rest length too, yes. And now I can create a popnet. And let's dive inside. So I want to use all geometry. Here I would like to have $f, let's say equal 1, but I'm going to take the start frame. So pass relative reference, and I don't want the inherit velocity and neither the guide. Okay. So now I would like to add a ground plane with a merge, not you. Okay, and use as well the pop grain. And just to have a better visualization, I'm going to create a pop color based on the ramp from the length of the velocity, from blue to white. Okay, and for now I'm just going to add a pop force like this. Okay, so this is what I have for now. I'm just going to reduce the number of clusters to have a quicker feedback from this one for each name primitive. And let's say I just want from my cluster 40, like this. So let's go back to the popnet, and actually let's call it grain sim and see what happened. Okay, so let's change a couple of things inside the pop grain. I'm not going to explain each parameter because again it's not the purpose of this tutorial, but let's change this one, let's say 100. I want a friction like 0.2. I don't want the accurate friction. I don't want the internal collision, and I want the explicit constraint, and with, let's say, a stiffness of 100,000, something like this. So let's see now what we have. So this is what I want. And let's see with the collision, with the ground plane. Okay. So now let's say I am happy with that. I'm just going to create a dot import. So let's copy this one. And I want the fetch with the pop object. Okay, and now I just have to copy with an attribute copy, let's say from this one to this one. And I want the position. So it doesn't work because of the for each, so let's put it there, and now it should be alright. Yes, this is okay. Okay, so before going further, I'm just going to pass an example that I have done to check what kind of effect we want to have there. So let's copy paste it and dive inside. So we have 3 different examples. So this is the main one, and here are 2 different examples of what we could do with the same technique. So let's focus on this one first, and let's play it just to see the result. So this is what I want to achieve. And let's see how we have done that. So first of all, I have a switch there to switch between two geometry. So this is the result with the second one. And let's go back to the first one and see what we have. We have a grid with 9 primitives. I'm adding a cust ID based on the Platinum, facet to get the unique point with splitted polygons. Here I do have a prim ID based on the premium but over the points. And here I do have 2 different trees that I want to plug inside the simulation based on those 2 different trees as well. So let's see the first one. With a fuse, I'm fusing all the polygons and I convert it to have lines. As we've seen before, I'm computing the rest length and the p-scale based on the rest length as well. And I'm doing the exact same thing there without the fuse. So if we dive inside the particle simulation, I'm just importing the first input here and here the second one. I'm setting a false and a color, a red color for the first input and a blue color for the second one, and with a pop grain for both. There is no real difference between both. And here I'm setting an attribute, the attribute broken, from 2 different ways. This one, each 5 frames, a new point have the value of 1 for the attribute broken. And on this one, I'm just setting like this, the attribute broken to 1 for the first point, so the point 0. Once I have my broken, I can directly go there, so inside the subsolver, and I'm checking between both, so the dot geometry, the pop object 1, which is this one, and between this one as well, this is the pop object, and this is this one. So I'm just copying the attribute broken based on the cust ID. I want to have the maximum of the broken based on the prim ID, and with that I'm creating a group follow. So if it is broken, then follow is equal to 0, so I will not follow the pop object 1, the pop object. But if it's not the case, then I will follow. And here, as you can see, I follow. So it means I copy the P attribute, the CD and the V from the cust ID, just for the group follow. And this is what I have. So for example, here I just set the broken to 1 for the Pythonium 0, and just one primitive is detaching. So if I change this one, and I can change as well the internal collision to 0, for example, and you will not see the repulsive force. Like this. Okay, so let's check with the other input as well what we have. Okay, and if I go back, if I import the result of my pop object 1, so it means the second input, I can copy directly the position from my original mesh. And this is what I have. So I have this simulation based on grain, and it's not going to detach, but the second one with the attribute broken is moving separately, and this is what we want. So let's check the other example as well. So there, and refresh maybe the viewport. So here I do have a collider as well. Let's show it here. So just this one actually, and I would like to display this one. And let's play the simulation just to see. So we can have that kind of things, and with a better resolution, and the fuse and the delta mush. Sorry, I'm going to get back the collider. So we have that kind of result, and it might be interesting for some effects, you know. So it's almost the same way, but if you go inside there, I didn't set any broken attribute here because it is inside. If you go here on remove broken constraint primitive, I've just added after the remove prim the attribute I had broken to 1. So it means this attribute is driven by the break threshold. So it means when it breaks, the attribute broken is going to be set to 1, and then the primitive is going to be splitted. And this is the exact same thing here. If we go inside, it is there. And that's it. So now we are going to redo this example. So I'm going to copy this one here, and this will be the start point. So let's zoom and create our two different trees. So the first one, I have to set a fuse. I need to convert to line, and I need to compute the rest length and the p-scale. But we have done that already earlier. So let's copy past this. And now I just have to copy past as well this one. So now let's create a popnet with the first and the second one. And I'm just going to copy past this one. I'm going to merge it. But I don't want to make them colliding or do something. So I will just set none. Here I would like to have the pop grain and the force, let's say. So let's say, I don't know, 1, and see what we have first there. So I need to set all geometry. Let's say $f equal 1. So let's play the simulation, and this is what we have. So I would like to set 1 for the explicit constraint and set 0 for the internal collision. So this is what we have. Okay, maybe a bit less with a bit more swirl. Okay, I would like to set the attribute broken for now, let's say on the Platinum 0. So let's add a pop wrangler here, and if at Platinum is equal to 0, then I at broken equal 1. Okay, so now I'm just going to copy past the top grain here and set the second input and the old geometry. I need as well to make this $f equal 1, and now I just have to add the subsolver. So let's go inside, and I want to use this one. So I don't want to stamp over each object. I would like to import this one like this and copy paste there with the pop object. Okay, actually let's call it first and second. It will be a bit more explicit. So let's have the second here and the first here. Okay, so now I want to make the second following the first one. So I just need to add an attribute copy there, and set the position from the cost ID. And now it's going to follow. So if I take a look with a pop color for the first one, let's make it, I don't know, red, and for the second one, maybe green. Okay, I'm not going to use the guide, so let's take it off, and for this one as well, and make this happening. So if I am adding the first one, I do have the same, and if I am adding the second one, I have the red here. It should be at the same position actually. Oh, it's just... So let's refresh all of these with a new viewport. Okay, now it's the same position, and this is what I expected, because we are just copying the position from the first one. But let's say I want to copy the attribute broken, like this, and now I want to use an attribute promote to get the maximum of the attribute broken over the primitive. So let's do it here. I want the attribute broken from the point to the point with the prim ID, and I want the maximum. And now I'm going to create a group and say if I at broken equal 1, then at group follow equal 0, else let's copy this one, equal 1. Oh, and I don't want that, so let's plug this one to this one and set the group. And just for better visualization, I would like the CD and maybe the V, let's say. So now if I go back and I play the animation, this is what I have. And it should be alright, because we want to hide that, yes. And maybe if I am setting the internal collision to 1, it will be a bit more explosive, like this. Okay, so now let's change the broken attribute and say if, for example, if at frame is superior than at Platinum, then I at broken equal 1. So let's see the result. Okay, And now let's say if at frame modulo, or not modulo actually, let's say divided by 5 is superior than at platinum, then I at broken equal 1. So this is a bit slower, but it's okay. And that's it. So it was not really complicated, even though I spent some time to find this way. And I've tried a lot of different things, so I hope you will like it. With this way you could as well sort, let's say, the point. For example, if I go there, actually here, I can sort it, and let's say by X, or by Z. So it means, if we take a look to the point number, then those ones are going to move first, like this. So let's see the result. And yes. And this is what we are going to apply to the skull. So I don't want that, I don't need it, because it's already there. And let's go back to the skull. Okay, so let's go, I don't want that. This, let's set it there. Actually, I will use this one. But before I need this there, I want to copy this one to have the second input. So let's set it there. I'm just going to copy the prime ID and the cost ID. So I want the prime ID there, let's say. And actually, to make it match, I need to use the fuse inside this one. Let's take out this one. And I'm going to set it before the time shift. Let's call it cost ID 2, because here I'm going to have a different cost ID, and I need to transfer it on the non-fused. So let's use int near equal near point. I want the second input and the position as reference. And I want to have the cost ID 2, so I at cost ID 2 equal point. For the second input, I want to have the cost ID 2 from the near point, like this. I'm just going to add a group as well, because I will need to delete, actually not delete but split. And let's set it there and call it fused. Okay, so now I want to merge it, like this. And let's see the viewport. So let's add the split. So here I have 2000 points, so it should be the fused, and let's plug this one there and this one there. And actually I don't even need to do it there. So let's set it here. Okay, so let's make a bit more room. And let's dive inside the popnet. So first of all, I need to copy paste this one and add a merge there and there with none. And let's plug this one there. I'm going to rename it first and second. And I want to copy paste as well what we have done here, the detach. And I want it, actually I don't need that. Neither you. Okay, so let's set so the first one, and this one should be the second one. I don't want the pop force here. This one, let's set 20. I want a red color for this one, so constant, let's use the red one here, and green for this one. Okay, now I have to set the broken attribute, so let's add a pop variable and say if at frame superior than at platinum, then I at broken equal 1. Okay. So okay, I wanted to check if the cust ID was the 2. So let's go back to the detach and set here the second, here the first, and here I don't want the cust ID 2. This is alright, this is alright too, and I want the cust ID 2. So it should be good, let's see. So let's say for now I don't want that, I just want you, but there is nothing. Why? So let's check this input, and I don't have anything. So maybe because of you. Oh yes, actually I have to. It's because of the convert line, I guess. Or maybe not. Let's copy paste it there. So here we have something. And here as well. But if I plug it there, okay. Yes, so it's because of the convert line. So actually, let's copy paste it and do what we wanted to do at the beginning. So is it the correct one? So 2000 points, and here, yes, this is the good. So let's check. And now I have it. And if I hide it there and I want it back, this one, so that's good. Even though, no, it's okay. I'm just copying the color here. So that's why it's not green. But I will get it after some frame, yes, there. So it works. That's nice. Okay, so now let's try to export it with this one. I want the second, and I want to check if it works. So let's add a new there. And it seems to be okay. Yes. So now I'm going to stick the position from the cust age, update a lot of different attributes, so for example the friction or the bonds, and a lot of different things. So let's do it.